It takes a lot of energy to get to space. Just getting a small satellite or a couple of people to low Earth orbit takes enormous towers combusting hydrogen and oxygen out their backs. We call these combusting towers rockets, and they cost tens to hundreds of millions of dollars apiece. This is the only way to get to space right now, but there's a theoretical way to get to space that would reduce the price 100-fold and get satellites and people up to the boundary between mid and high Earth orbit, the space elevator. A space elevator is a simple concept. It is an elevator that reaches up into space, but there are many complexities with reaching an elevator up into space, which is why we haven't built one yet. The first question is, how high should it go? It should get up to a height where it is in orbit around the Earth. Orbiting is just a continuous freefall around the planet, so if the top of the elevator was placed in orbit, then it would be suspended in weightlessness and able to hold up the rest of the elevator. Unfortunately, not just any orbit will work. The ISS orbits the Earth once every 90 minutes. If a space elevator were placed in orbit at that height, its bottom would be dragged around the entire planet once every 90 minutes. Not very useful. Thankfully, orbital period increases as altitude increases, so an orbital period of 24 hours to match the planet's spin could be achieved at a specific height, 22,200 miles above the surface, known as a geosynchronous orbit. Also, the elevator would have to be placed on the equator, or else it would swing north and south over the course of a day. Another thing about the space elevator is that it would be super heavy. It is 22,200 miles of material. Therefore, at the upper end, a space station should be placed. It would be like a giant airport. If it was massive enough, and placed a little higher than geosynchronous orbit, then centrifugal forces will pull it upward, creating a counterweight to suspend the elevator. Even with its weight supported, the elevator would be under a lot of tension, so it would need to be super strong. Also considering space junk, micrometeorites, solar radiation, and the countless other deadly things in space, the elevator must be able to take a lot of damage. No currently existing material is guaranteed to work for this. Our tallest buildings aren't even a mile tall, let alone 22,200. Carbon nanotubes or graphene might be promising, but right now it's impossible to tell. What I can say for sure is that it must be super light and super strong. Then maybe it'll work. Also, where are we going to find that much material? Certainly not on Earth. It would be much easier to mine asteroids for the material. Also, building the elevator in space would be a lot easier than trying to build bottom up without the support from the top. How do you maintain a 22,200-mile track? That is like the upkeep on a track going around the whole equator, complexed by the fact that it is vertical, and you can't just remove sections of the track to repair or else it'll fall apart. Maybe a team of 1 million worker robots zipping up and down the track to fix things and carrying scaffolding with them for support whenever replacement is necessary. Also, a slew of problems come with the elevator car itself. First off, how long would it take to climb the elevator? The fastest train in the world is the CRH 380A, a 300 mile per hour Chinese train. Even with this speed, it would take 3 days to climb the elevator, so cars would need to be big enough to carry people for 3 days nonstop. That means beds, hotel rooms of sorts. Or maybe there could be rest stops dotted every quarter up the elevator. This would keep car size down, but increase the time it would take to climb up. With a voyage taking many days, more than one cable would be wanted. Otherwise, trips up would only come every week, or with the rest stop idea, every day or so. Maybe 10 or 20 cables could work depending on the demand of space travel. Another possibility is different elevators around the planet, all reaching a height of 22,200 miles and giving Earth a sort of ring. How would you power the ascent of the cars? Normal elevator cars are lifted up by ropes in the shaft, but here the tether would be static, and the car would propel itself like a train. It would take a lot of power to climb for days. Maybe the cars would have nuclear reactors, fission or fusion, or maybe power could be beamed up by lasers. A final note on space elevators. A collapse would be catastrophic. If the elevator broke near the top, then it would lose the support from the counterweight and fall toward the planet while the counterweight fell into space. The people in the counterweight might be fine, or they might be lost in space, depending on how high up it is. But people on the elevator, or living on Earth near the equator, would be in extreme danger because the elevator would come crashing down with more energy as it went along, destroying everything along the equator. If it broke near the bottom, the whole elevator would rise up into space and maybe be saved and brought back to Earth. Overall, a space elevator would progress humanity into space with cheaper travel there. There are just a handful of problems that must be sorted out first.